Hi everybody, Steve here. Today I'm going to be showing you some of the code in Sedimentary Groove. This is a project I made for fxhash a long time ago now, April of 2024. This is a params project, so the user can change things like the color palette, or they can shuffle the color. So if you want the same color palette but the colors in different places, you can get that. It also features this lovely frame, so I'm going to talk about the frame as well. The video will be timestamped, so if you want to skip to different parts you can, and there will be in the video description a link to the code that I'm going to present today. There's also going to be a link in there to some starter code. So if you want to follow along with me, you load up that starter code and that'll make it a little easier when we get to programming. I want to start with the frame because it's actually quite simple. It's a series of rectangles in a for loop, no fill. I pick a stroke color from the palette, and then I draw a series of rectangles smaller and smaller, and as each rectangle is drawn, I am reducing the brightness of that color. So the largest rectangle has the most brightness and the smallest rectangle has the least brightness, and that's all there is to it. But it looks very nice, doesn't it? Next, I want to talk about that color shuffle feature. So I'm using a color palette table. I've talked about this before. Each line here is a palette. It's an H, S, and B, and there are 7 colors in the palette. So this is color number 0, and this is color number 1. But I want to shuffle these around so that the order is different, which means I need to put them in a new array in a different order. So how do I do that? So first, a number of the palette gets chosen. That is palette num. And then I call the getPalette function immediately after that. And this function has its own random seed, seed number 2. And I have this array called numbers. What I'm going to be doing is picking randomly from our chosen palette, and I have to keep track of what colors remain that I haven't already picked from my chosen palette. So that's why I have this array called numbers. So these are the currently available numbers from the palette, 0 through 6. And as I pick, I'm going to remove the numbers that I've picked. And the final palette is going to be in this new array called palette. So I have a for loop going 0 to 7. The number that I'm going to pick the first color. It's going to be from this numbers array, the length of that array. So it's 7. So I'm picking a number between 0 and 7 and flooring that. So I get 0 through 6. So the first time it picks, the col num that it picks is going to be the same as the number in the array. So if I picked color number 5, it's going to be this number. So then I'm going to pull from the color table color number 5 from the original palette, and then I'm going to get an H, an S, and a B, and I'm going to push that into the new array, the palette.push. So I'm going to push this new HSB into this palette array, but now I need to remove the color that I've picked from this numbers array. So that is what this is, numbers.splice, the color number, and I'm removing one item. So if it's item number 4, I'm going to be removing item number 4 from the numbers array, and the new numbers array is going to look like this. So the next time I go through to pick a color, it's going to be the number.length, instead of being 7, is going to be 6. So if I pick color number 4 from this array, it's actually going to pick color number 5 from the original palette. You see how that works? And by the time I get to the end, there'll just be one color left. Let's say this is the final color available. So it'll automatically pick that color, and that'll be the final one that goes into the array. So now that my palette array is done, as I go through my code, I use getColor to get the H, S, and B out of that new palette array. So now we're going to go into the meat of the project. This would be the time if you want to code along with me to grab the starter code. See that in the video description. What the starter code has is, first it has a color table of 5 colors. I preload the color table. I'm creating a canvas using the window width, window height, changing the color mode to HSB mode. I grab a palette from those 5 available palettes, and I'm just giving it a background of 0. Give me a black background to start with. This is a get color function that will be used later to grab a color from that color palette. This version that we're going to do together does not have the color shuffling feature. And then this little function at the bottom is so you can hit S to save your canvas. We're going to be using Perlin noise to create a color map of the noise using the different colors from the palette. So for the Perlin noise, we're going to need a resolution on that noise. Let's say 0.003 to start with. We're going to need a for loop for the width and the height. So let's do for x equals 0, x less than the width, x plus plus. You may have seen me do this coloring thing with Perlin noise in the past, and I would do plus equal 5 or something like that. But here, for this project, I'm going to want to color every single point differently. So we're just doing plus plus for y equals 0, y less than the height, y plus plus. I just realized I have an x plus plus here. So y plus plus there. And then open parentheses. So then we're going to grab some noise, the x times the resolution, comma the y times the resolution, and then we want a color from that noise. So let's say the color is going to be n times, we got 7 colors, and we're going to need to floor that to grab the color, so it's an integer between 0 and 6. And then once we have a color number, then we can get the color call, and we're going to be making a point. So instead of using fill, we're going to use stroke, HSB, and then we're going to make our point at x and y. Now this is going to take a while because we're drawing a point on every spot on the screen. Let's do a save on this. Actually, you should duplicate it so that you can do your own save. So now that we saved it, let's hit play, and it's giving us a no protect. It's worried that we're going to get into an infinite loop, so let's do no protect, and there we go. It's done, but it did take a while. So to reduce the amount of time that this takes, we're going to use the pixel array. I have not used the pixel array on this channel before yet. The pixel array is built into p5js. There are some functions that we can use. Every point on our canvas has 4 items in for each pixel. So there's an R, a G, a B, red, green, blue, and A, alpha. So the first thing we have to do is we're going to load pixels at the beginning, and then at the end we're going to be updating our pixels. So let's just add that. Let's see, after this loop we're going to have update pixels. So we're not going to be drawing a point anymore, and we're not actually going to need the stroke HSB either. But since we have an HS and B, we need to convert that in order to use the pixel array, because the pixel array uses RGB, not HSB. We'll make this into a color that we can use. So let's say it's color HSB equals color HSB. For the pixel array, we need to know what position we're at in that pixel array. So how did we do that? Let's say we're on the second row way at the top, but we're on the second row and we're like 5 digits in, 5 pixels in. That is, if the width is, say, let's just say it's 100, just to make it simple. So the width of the canvas is 100, and we're 5 pixels in on the second row. That would be pixel number 105. Except that every item in the array has 4 things, the red, green, blue, and alpha. So it's 105 times 4, whatever that number is. That's the position in the array for this pixel. So the position is going to be the x plus the y, the height, times the width. How does that make sense? Well, let's say we were on the third row and we were 5 pixels in on the third row, and the width is 100. So this is 100 plus another 100 plus 5. So 205, and then multiply that times 4. So the y down times the width plus the x, and then multiply all of that times 4. And that's the position. So now we know our position, we can start replacing the pixels. And we say pixels pause. This is going to be the red. So we want the red of col HSB. And then the next one is green. So that's going to be position plus 1 is going to be green col HSB. And then the third one, pixels pause plus 2, that's going to be our blue col HSB. We don't need to replace the alpha. The alpha will just be full alpha, so it can remain the way it is. But the alpha would be pause plus 3. Let me do a save on that, and we hit play again, and it did the same thing, but it did it much faster this time. I am getting an error though. Let me see. Sketch.js line 18 color was expecting a number for the first parameter. So why did that not work? Well, I can't figure out why I'm getting that error. It should be all working. It obviously is giving us an image. So I'm just going to tidy my code and continue on and forget about this error. And we can hit play again and we get a different image. So this is good. One problem that we have here, we are getting 4 colors here. Let's play it again. 1, 2, 3. And here we've got 4 colors again. So we're only getting 4 or 5 colors instead of all 7 colors that we want represented. What happens with Perlin noise out the box is that it tends to favor the middle. So 0.5 is the middle, and the 0 and the 1, very close to 0, very close to 1, don't get represented hardly at all, almost none. We want to fix that. That's fine if you want to use Perlin noise to make a mountain range, but if you want to represent colors, if you want to make a flow field, that's no good. So we're going to add a little code so that our colors are more equally represented. I don't want to go through this in detail because I've talked about it before on the channel. I'll link to a snippet of video where I discuss how I fix this. But let me just add 0.033 here. Then we'll say n equals map n from 0.3, 0.7, 2, 0, and 1. Then if n less than 0, n plus plus, and if n greater than 1, then n minus minus. Now, we grab the color equals the floor of n times 7. Let's try running this again. There we go, and now we're getting more colors represented. Now, one thing this might do is it maybe looks like you've zoomed into the Perlin noise, so you might decide to reduce the resolution here a little bit. All right, that looks pretty good. So this brown right here running through the center, because it looks like a river, is probably the very middle of the color palette. Whereas islands, like probably the black, is the very end of the color palette, either the first number or the last number. I just figured out why I'm getting errors. I've got n times 7 here for 5 colors per palette, but actually I only gave you 5 colors per palette in the starter code. So I need to change that to n times 5, and now I don't get any errors. So the next thing we're going to do is we're going to create a gradient. So let's say this was color number 3. Before we floored it, the color was 3.001 to 3.999. We can use those fractions, 0.001 to 0.0999, to reduce the brightness. We want to do that after we grab the HSB, but before we convert it into this call HSB color. So we're going to take the brightness, B minus equal, so we're going to subtract from the brightness. We're going to take the fraction of the n times 5. So this is a formula for grabbing just the fraction part of that. And we need to multiply that by something. So let's multiply it by 20 to start with to see what that does. There we go. We got a little bit of a gradient here. So in other words, if this fraction was 0.999, we're now subtracting 20 from the brightness. If that fraction was 0.001, we wouldn't be subtracting hardly anything from the brightness. Let's increase this to 50, and that looks better to me. So we'll use that. Let me do colnum2 equals colnum. And then we're going to just update this to colnum2 and colnum2. That'll give you the same results. Now I'm going to do something weird, and I have to be honest with you. I don't exactly understand why Sedimentary Groove works the way it does. I was trying stuff, just playing around, and I got that effect. And so I'll show you the code that I did to get that effect, but I don't entirely understand why it works. But that is an important part of generative art. Just playing around with stuff, see what happens, get surprised by what happens, and go with it. So here's what I did. I took the fraction of the color number, divide by 10, multiply by 10. Now if I do that, I still get the same thing. Not exactly the same thing. I get something similar to what I had before. But remember, it's taking the fraction, so it's really knocking off the whole numbers from this. So it's really getting a whole different set of numbers. This actually should be giving me numbers all the way up to 9.9. So I'm not sure why I'm not getting an error from this. I should have to do if colnum greater than 5, then subtract colnum minus equal 5. Subtract 5 from that so that I still get a number between 0 and 5. But instead of doing just multiply by 10 here, I'm going to do a random, say 9 to 11, and let's just see what that does. We get this, getting a little closer. I am getting an error message here. I think because with the 11, I'm actually going past 10. So let's do another if statement. If colnum greater than 10, then let's subtract 10. Still getting an error. Oh, I've got colnum instead of colnum2. Let's fix that. There we go. No errors. So this is what I'm getting. Now, what happens if we floor this? We'll put like that. So we get this. Now we're going to do another little bit. We're going to add some lines in there so that it looks more like this, these black lines. So the way I'm going to do that is also kind of odd. We're going to have a check number, and we're going to have the evens are going to be black and the odds are going to be colored. So first we're going to need a skip number. So skip num we'll say equals to 5. So right here we're going to check a new variable called check the floor of colnum2 times skip num. I believe, is that what I called it? Skip num? Yes. So colnum2 times a skip num is going to give us a number that's either going to be even or it's going to be odd. And we're going to check to see whether it's even or odd. If check divide by 2 equals floor of check divide by 2, and we need 2 equals in an if statement, then we're going to do something. Let's see, I got one too many parentheses there, I think. So this statement here would return true if the check was an even number. So if it's even, instead of the call HSB being this color, I want call HSB to be equal to color 0, which is black. And if it's not, if it's odd, then we'll do all of this stuff up to here. And let's tidy that code and see what happens. There we go. That's Sedimentary Groove. I'll hit it again. Yeah, it looks great. I don't understand it. I'm sorry. I wish I could explain why this works the way it does, but it works. That's what I did. So we can mess with this skip number. If I said I wanted the skip number to be, let's up it to 20, that's going to give you a whole lot of skinny black lines. So what happens if we don't floor this? We just take out the floor. We get that. Let's see what would happen if we, say, took this and multiplied it by 10 instead of 5. Something like that. Let's reduce this to, say, 0.001, and let's up this to, say, 20. Maybe we reduce this even more, 0.0002. Yeah, so anyway, you can play with this. I'll put it back to how I had it to start with. The other thing I did with the project was took out entire colors so that there was some blank space in there. We're getting a color number here, but what if we said if this call equals, say, 3, then we want call HSB to be call 0. And we only want it to do this part if its call is 0, 1, 2, or 4. And we get, it knocks out some of the color. Or we could say, well, if call equals 1 or call equals 3, we'll knock out call 1 and call 3, and only leave call 0, 0, 2, and 4. So that's how I made the blank spaces in the project. That's it for today. I hope you learned something. I'm not sure. This wasn't my best video because I don't entirely understand the code that I've written, and I'm sorry. I hope you learned something anyway. If you liked the video, you can give it a like and consider subscribing to the channel. Ring the bell for notifications. Thank you for watching. I'll see you in the next one. Bye now.